Good morning, students. Today we are going to discuss about fuel cell. Fuel cell and components of fuel cell and the working of fuel cell, classification of fuel cell and so on. So first of all, we start from the fuel cell. Fuel cell. A fuel cell is an electrochemical device in which the chemical energy of conventional fuel is converted directly and efficiently into low voltage direct current electrical energy. Fuel cell systems generally operate on pure hydrogen and air to produce electricity. So first of all, we are discussing about the history also. So the fuel cell was developed in 1839 in England by Sir William Groves. However, the application of fuel cell was first demonstrated by Francis T. Bacon in 1959 when his model generated 5 kilowatt at 24 volt. Its practical application began during the 1960s when the US space program chose fuel cell over nuclear power and solar energy. Fuel cells provide power to the Gemini, Apollo and Skylab spacecraft, continue to be used to provide electricity and water to the space shuttles. And some of the applications of the fuel cells are also there. So application of fuel cells, number one, that is domestic use, automotive vehicles, central power stations, defense applications, space projects. Fuel cells are primarily suited for low voltage and high current applications. And now the components of fuel cell. So these are the components of fuel cell: anode, cathode, electrolyte, container, separators, sealing, fuel supply, oxidizer. These are the components of fuel cells, and we will discuss the use of all the components in next. This is the working of fuel cell. So here the schematic diagram of a fuel cell. The fuel gas diffuses through the anode and is oxidized, thus releasing electrons to the external circuit. The oxidizer diffuses through the cathode and is reduced by the electrons that have come from the anode by the way of external circuit. The fuel cell is a device that keeps the fuel molecules from mixing with the oxidizer molecules, permitting, however, the transfer of electrons by a metallic path that may contains a load. Of the available fuels, hydrogen has so far given the most promising results. Although cells consuming coal, oil, natural gas would be economically much more useful for large scale applications. So this is the simple working of fuel cell, and we will discuss later the specific one kind of the fuel cell in detail. So now the classification of fuel cell. So fuel cell may be classified as follows based on the type of electrolyte: alkaline fuel cell, that in short AFC, phosphoric acid fuel cell PAFC, polymer electrolytic membrane fuel cell PEMFC, the molten carbonate fuel cell MCFC, solid oxide fuel cell, SOFC. So these are the short form of all these kind of the fuel cells. So this is the classification on the based on the type of electrolyte and based on the operating temperature. So based on the operating temperature, that is low temperature, medium temperature, high temperature and very high temperature fuel cells, and all the temperatures are also defined here. You can see that this is the low temperature fuel cell that is working 25 to 100 degree centigrade, and the medium temperature fuel cell that is 100 to 500 degree centigrade. This is not below. And high temperature fuel cell that is 500 to 1000 degree centigrade, and very high temperature fuel cell that is above 1000 degree centigrade. And based on the type of fuel cell and oxidant, these are the 7 type of fuel cells are there on the based of fuel and oxidant. Hydrogen oxygen, that is H2O2 fuel cell, hydrogen air fuel cell, hydrogen oxygen fuel cell, ammonia air fuel cell, synthesis gas air fuel cell, hydrocarbon air fuel cell, hydrocarbon air fuel cell. This is one gas and this one for liquid. So these are the classification of fuel cells according to the previous one. First one is according to the electrolyte, second one according to the temperature, and third one is according to the fuel and oxidant. So we will discuss after this classification first H2O2 fuel cell. So before going to the H2O2 fuel cell, we have to discuss about some advantage and disadvantages of different fuel cells. So first one for PEM. PEM, I have already told you, polymer electrolytic membrane fuel cell. So this one up, that is advantages, and down, that is disadvantages. The first line for the advantages and second line for disadvantages in all the cases. So first for polymer electrolytic membrane fuel cell. That is, this one advantage is quick startup, easily available auxiliaries, and disadvantages water management, susceptible to impurities. And in case of AFC that it means alkaline fuel cell. The AFC, that is more reliable, and some disadvantages is handles CO2 poorly. And MCFC, so what is this? MCFC, molten carbonate fuel cell. The molten carbonate fuel cell, that is advantages are there, so that can operate with a wide range of fuels, but disadvantage this high temperature, corrosion, thermal fatigue. These are the disadvantages of MCFC. And last one is SOFC. The advantage the same, they can operate with a wide range of fuels, but the disadvantage extensive auxiliary parts and slow startup. So these are the advantages and some of the advantages and disadvantages of different type of fuel cells. Now we'll discuss. Now we are starting hydrogen oxygen fuel cell, that is H2O2 fuel cell, or we can say alkaline fuel cell. So here you can see the diagram of H2O2 fuel cell. So in this hydrogen and oxygen are used as a fuel and oxidant respectively, as these elements are most reactive with least complications. The electrolyte is potassium hydroxide, QH, which has high electrical conductivity and is less corrosive than acids. So this is the simple schematic diagram is shown in front of you. So construction of this diagram, it has 3 chambers separated by 2 porous nickel electrodes. These are the two polars, nickel electrodes. The anode and cathode, you can see this one, anode and cathode. The middle chamber between the electrodes is filled with a strong solution of this is KOH, solution of KOH, or we can say this is electrolyte, solution of KOH or potassium hydroxide. The surface of electrode are chemically treated to repel the electrolyte so that there is minimum leakage of potassium hydroxide into the outer chamber. The gases diffuse through the electrodes undergoing reactions are shown in the next slide. The reactions, this is the working or the reactions are shown below. Here we can see the KOH, that is K plus plus, that is OH negative. Then H2 plus 2 OH, so that produce the 2H2O. 2H2 plus 2H2, that is 4H2, and 2O, that is 2 plus 2 electrons. The electrons so produced build up a negative potential and more towards the cathode through an externally connected circuit. Here we can see that towards the cathode, that it means here this is the cathode, so this is from the anode to cathode, so towards the cathode. The electrons are picked up by the oxygen atoms available at cathode, react with water present in the electrolyte to form hydroxide. To form the hydroxide. So here we can see the hydroxide ions. So this is the reaction. Half O2 plus H2O, there is 2 electrons, or this forms 2OH. 2OH, that means hydroxide ions. These ions combine with hydrogen ions. This is the hydrogen ion to form water. Hydrogen ion and hydroxide ion, that is produce H2O. So overall reaction, overall cell reaction and overall reaction takes place, that is 2H2 plus O2, that is equals to 2H2O plus electrical energy. The water formed is drawn off from the side, that is side, it means here we can see this is the side, or here we will get the water. So this is the H2O2 fuel cell. So thank you very much.